Welcome. All right, so ladies and gentlemen, what we have here is tan of theta equals 1/2. And what we want to do is be able to evaluate all 6 trigonometric functions given this one value. All right, and so what they're asking us to do is, to go and use just an acute triangle. So let's go ahead and have right here. So use a acute triangle, say here's going to be our angle theta, and that will be our right angle. Because remember, using trigonometric functions, we have to make sure we have a right triangle. So a couple things to remember about the tangent function is the tangent function, remember, represents a ratio of the opposite side over the adjacent side of a triangle. So when we're looking at if here's going to be our angle theta, the opposite side is going to be over here, and the adjacent side is always going to be between your angle and your right angle, which would be 2, whereas the hypotenuse is always directly across from your 90-degree angle. Now, we are given tangent, but we need to find sine, cosine, and then all the reciprocal functions. So we're going to have to know what is going to be the hypotenuse. So to do that, we can use the Pythagorean theorem. Now remember the Pythagorean theorem, we use a squared plus b squared equals c squared. But remember, a and b squared just represent the legs, where c squared represents the hypotenuse. So I can call that c if I wanted to. All right, so let's just say 2 squared plus 1 squared equals c squared. Now remember, again, it doesn't matter what a and b, they both represent the legs. So it doesn't matter which one I really choose how to write that. So it's going to be 4 plus 1 equals c squared. So that's 5 equals c squared. Take the square root, take the square root. C equals the square root of 5. But since we're talking about the hypotenuse of c, that's only going to be dealing with the positive distance. So therefore, it's just going to be the positive square root of 5. All right. So now let's go ahead and determine what is our sine of theta, our cosine of theta, and we know now the tangent of theta, which is equal to 1/2. So the sine of theta, remember sine is, opposite over your hypotenuse. So we go back over to our triangle, and we say, all right, the opposite side is 1 over the hypotenuse is square root of 5. But we cannot leave our answer with that. We're going to want to rationalize the denominator. So to do that, I multiply by the square root of 5 over the square root of 5. And therefore, my final answer is the square root of 5 over square root of 5 times square root of 5 is square root of 5 squared, which is just 5. Then I go to the cosine, which is your adjacent over your hypotenuse. So that's going to look something like this. So adjacent over the hypotenuse. So therefore, that's going to be 2 over the square root of 5. Again, just like the sine, we need to rationalize the denominator. So I multiply by the square root of 5 over the square root of 5. And therefore, by multiplying across, that's going to leave me with 2 square root of 5 over 5. Now, the tangent we already figured out, so we're good with that. You know what? I'm going to try to sneak these in here. And maybe just to help you guys out, I'll do them in a different color. So I'll do, because I know these are going to be pretty simple. So if I have sine, the reciprocal of the sine is the cosecant. Cosecant of theta represents the reciprocal, which is the hypotenuse, over opposite. And the hypotenuse, again, is square root of 5 over the opposite side, which is 1. So that just leaves us with the square root of 5. The reciprocal of cosine is going to be the secant function. And therefore, if cosine is adjacent over hypotenuse, secant is going to be the hypotenuse over adjacent. So that's going to be the square root of 5 over 2, which we'll just leave at that. Then we have the cotangent, which is the reciprocal of your tangent. So that's just going to be your, I didn't do this, that's opposite over adjacent. So the cotangent, that's going to represent the adjacent over the opposite, which in this one was just going to be 2 over 1, which just equals 2. So there you go, ladies and gentlemen. That is how we evaluate all 6 trigonometric functions when given a value of one trig function. Thank you very much. By using an acute angle, something like that, right? Thanks.